Okay, good morning, everyone. I want to welcome you to the first breakout session for EDC. This is the Automated Traffic Signal Performance Measures Innovation Breakout Session. My name is Eddie Curtis, and I am with the Office of Operations and Resource Center, and I'm one of the co-leads for the Automated Traffic Signal Performance Measures Technology Initiative in EDC. Today, joining me on our team are Sean Gottfredson from Overland Park, Kansas, and I also have Dwayne Thomas from the Kentucky division, where he serves as an area engineer. And so we're going to be providing you sort of an overview of the ATSPM technology. We'll give you all the background, and then ultimately we'll talk about the implementation approach. All right, so I think we have 9 state DOT folks, 5 FHWA, 1 local agency, Sean, and 2 MPO representatives, right? I think we have 2 from New Hampshire, 2 from Vermont, 4 from Maine, 1 Massachusetts, sound right? 2 from New York, 1 from Rhode Island, and 2 from Rhode Island. Okay, sorry, missed that. And anyone from Connecticut? Okay, no one from Connecticut. Okay. All right, so not a lot of signal background in the room, so we'll try to keep this relatively high level. Like I said, we're going to give you some background. We'll then go to Sean, who will give you some agency experience with automated signal performance measures, and then we'll go over our overall approach to EDC4 with this technology, and hopefully engage you in a little bit of discussion about how you might implement this in your state, based on sort of where you are. So just cutting to the chase, what is automated traffic signal performance measures? So when we talk about this technology, it's effective. It has 3 components. All right, so the first is a suite of performance measures. The second is data collection. And then the third is analysis. So suite of performance measures, set of data collection tools, and then data analysis tools. And all of this, when we start talking about adoption, which I'll talk about throughout the presentation, is how do we get to an objectives and performance-based approach to managing traffic signals. All right, so that's our definition of automated traffic signal performance measures. Why are they important? We do a number of traffic signal reviews. When I came onto Federal Highway in 2006, and my background is I've been in the industry about 20 years. Prior to Federal Highway, I worked for the City of Los Angeles in their traffic signal operations division. Los Angeles has something like I think they're up to about 5,500 traffic signals. But we do a number of traffic signal reviews where we go around, and this is on invitation from the agency, and they're looking for methods or strategies to improve their traffic signal program. And so one of the things we'll typically do is we ask, define what traffic signal operations is to us. What does it mean to manage a program? How do you know that it's working? And my favorite response came from an MPO in Fargo, North Dakota. And their definition of traffic signal operations was the signals go red, then green, then yellow. Sometimes they work, sometimes they don't. And when they don't work, we fix them. And so that's pretty indicative when you go around the country and you start to have a conversation about traffic signal operations. Most agencies are not too far off of that. But this technology in particular, I think, is a great opportunity to understand how traffic signals are performing or working, and not just in operations, but there's also operations, there's maintenance, there's the management and administration of the traffic signals in terms of asset management, budgeting, planning, and then also all of this has linkages into design. Because I think as we move into a more objectives and performance-based approach, a lot of this is going to require detection and communications. So where do you put that infrastructure at signalized intersections? And then you think about the larger program, you know, how does a traffic signal program help the organization understand how it's achieving its organizational goals? So you typically see things at the state DOT level like safety, there are mobility goals, high quality customer service, and then the big infrastructure one, state of good repair. How do we know that our infrastructure is actually reliable? Okay, so when we think about, so I talked about what is a traffic signal program, how do we know if it's working? We've had a number of national assessments that have been oriented around gauging the state of the practice. This is the traffic signal report card, and these were completed in 2005, 2007, and 2012, and we're actually currently working on the next iteration of this. It won't be a report card, it will be a benchmarking report, but that one's due out in mid-2017. All right, but when we think about this report card, it's really shown that we have two very weak areas. I mean, overall, the grades have been D-, D, and D+. And the two weakest areas have consistently been program management and performance assessment. If you think about program management, that's where we're going to get into the objectives and goals of the program. That's where we're going to talk about performance measures. So it follows that if we're weak in program management, then it's a logical follow-on that performance assessment will be relatively weak. And it turns out that traffic signal systems tend to be very oriented around complaints for their primary performance measure. And that ultimately results in a lot of reactive operations and maintenance activity. And typically, if we do any performance measurement, it's usually going to be like a before and after study that'll happen just before and after a traffic signal retiming. And we'll get into more about that throughout the presentation. So let's talk about the traditional process. So traditional operations, we model a lot and we measure a little. So what does that look like? The Highway Capacity Manual is sort of the guiding document for how we design traffic signal timing. And it's been incorporated into a number of the software tools that are used. And basically what happens is the tool will accept hourly traffic signal volumes, right? So the beast eats traffic signal volume data. And so we go out and we collect turning movement counts, typically manually, and that gives the vehicle trajectories at the intersection. And then those are fed, and that might happen for a week or more, but usually that model only takes hourly data, so we have to compress that data into a 1 hour data set and then feed that into the model, and then that pops out. That next item on the bottom there on the left is a time-space diagram, and that's what we use to actually coordinate or design the coordination for the signals. That's input into a traffic signal controller that sits out at the intersection. And then if we want to evaluate that, as I said, we'll go out and we'll do a before and after study. Typically, this is a manual floating car study where you're measuring travel times. And some of this has been automated now. Some agencies are using probe data. And then as an outcome of that, we'll go back and we'll tweak the timing at the intersection. So if it's not working consistently with what we planned with the time-space model, we do the floating car study, so we may go in and make a few tweaks. All right, so that's the traditional process. And this happens maybe every 3 to 5 years, I think, is considered best practice. And in between the time that we do these retimings, then we tend to get complaints as our performance measure. So a complaint comes in, that tends to bypass the modeling because now we have a problem. Maybe it's a pedestrian time that's too short, maybe it's a bicycle that's not being detected, maybe it's a side street that doesn't have enough time, or maybe it's just vehicles not able to flow down the street without stopping at multiple reds. All right, so then we go out and we'll actually make some changes. And typically, because that model's been designed on representative data for the intersection, when we start to get complaints, now we're getting very specific items and we make these tweaks, and so they may not always work. So what happens generally is we get more complaints. All right, so we make a change in response to a complaint. Typically that results in more complaints, and so eventually the signal timing tends to move further and further away from that design, and so you wonder, why don't these signals work? Why can't I drive down the street without stopping? This usually happens over time. We start with a good plan, and then it just deviates over time as an outcome of all of the little small changes. If we want to get into maintenance, maintenance tends to be very similar. If we talked about the total cost of maintenance, it's an outcome of the frequency of preventative, routine, and emergency maintenance. So if you start out on the left of that curve and you do preventative maintenance very frequently, high frequency preventative maintenance, it costs a lot, but it reduced the amount of emergency maintenance that's required because you're replacing those components proactively. Obviously, you don't want to be too far to the left or too far to the right of that curve. You want to be somewhere in the middle, and we would suggest that that's an objectives and performance-based approach. And automated signal performance measures can provide not only operations measures, but they're also a set of maintenance and even some design and management measures that can be pulled out of that data set. So let's talk about where this technology came from. What's the origin? There were two, I have to say, in addition to a lot of ongoing academic research, and I am a member of the TRB Traffic Signal Systems Committee, and I've been hanging around that committee since about 2005. So I've seen a number of papers on this topic, and I think a lot of those papers motivated the submission of an NCHRP problem statement that got picked up in, I think that was 2004. So we had two NCHRP projects. 379 was specifically on traffic signal performance measures, and then I think 366 got more into infrastructure, how to design for performance. There's also been a pretty good level of FHWA research, and part of this technology actually came out of the ACS Light research that was done for adaptive control, and that started 2004, maybe wrapped up around 08, and then there was some effort to implement that technology, and actually adaptive control was in EDC 1. So then we move forward. There was a transportation pool fund study that was initiated in 2013. That was by Indiana DOT, and there were 12 states that actually signed. Actually, there were 11 states, FHWA, and the city of Chicago that participated in that pool fund. And actually, New Hampshire is one of the states that's part of that pool fund. But out of that pool fund study came the suite of performance measures and a lot of the methodology in terms of how to compute those measures and information about the infrastructure, what detection, what communications, what control do you need to pull those measures out of the infrastructure. The analysis portion was developed by Utah DOT, and they developed some open source software and began to promote that software through the AASHTO AII initiative. And they did that from roughly the end of 2013, and they're wrapping that up now with the workshop that I'll mention later in the presentation. And here we are coming with Everyday Counts 4, and our hope is that we can widely implement this technology beyond its current footprint. Okay, so going back again to the definition. So we said it's a suite of performance measures that support objectives and performance-based approaches to traffic signal maintenance, operations, management, and design, supported by tools. And we're going to specify that these are product-neutral tools. There's a number of options to implement this technology, and that's the technology component is the data collection and the data analysis. All right, so let's go through this. So when we say a suite of measures, this is an example of the suite of measures. And because there have been a number of states involved in the pool fund study, a number of these measures have been developed by the state DOTs that were involved. So we have, for operations, we have arrivals on red, there's pedestrian bicycle delay, there's a Purdue coordination diagram, which I think Sean has in his presentation, and he'll go into a little detail on that. There's split failures, queue length, split monitoring, and travel time. Under maintenance, we have things like false cause, detector failure reports, preemption details, and communications failures. And the preemption details is actually pretty important. FRA put out a technical bulletin, I think earlier this year or late last year, and it talked about the need to have monitoring devices that signalize intersections for preemption. And up to now, there's not really been a real specification on a device for that or what preemption details needed to be collected. So this is a mechanism to accomplish that. And then under safety, again, we have split failures, yellow and red actuation, speed, and again, preemption details. And I'll go through some of this. So how many of you have a fitness tracker on your wrist or somewhere on your body? All right, so 2 fitness trackers in the audience. Okay, so why did I ask that question? All right, so if we really want to understand automated signal performance measures, a very good analogy for this is fitness trackers. Fitness trackers are effectively collecting higher resolution data. Inside a fitness tracker is an accelerometer, and it's just collecting high resolution information about the movement of your body. And then that data is then translated using data analysis tools into a number of measures. And this is a screen capture from my fitness tracker, of course, one of my better days. So this, on September 3rd, I took 16,000 steps. Says I climbed 46 floors. I walked or ran 6.7 miles, burned 4,300 calories, and exercised at least 155 minutes. That's pretty impressive, that particular day. But that's effectively what we're doing with higher resolution data, right? So there's a high resolution data collection process that's collecting information about everything that happens at the intersection, every detection, what's happening with communications, what's happening with the indications. It's recording that, and then it can be translated into a number of measures, and I showed you that suite of measures earlier. So what are the benefits? All right, so these benefits, we have a technical team that we pulled together, and we spent some time deliberating about these benefits, and this is what we were able to extract. And this is really from the agencies that have been using this. The biggest benefit is that it provides the information that you need to transform maintenance and operations from reactive to proactive. As an outcome of doing that, they're lowering cost, they're able to deliver a higher quality of service to their customers, and there's certainly improvements in safety and efficiency. If we're going to expand into safety and efficiency, we've been able to do a number of safety monitors or safety-related performance measures, better distribution of green time around the intersection, and certainly the ability to incorporate an objectives and performance-based approach. And then in maintenance, there's asset management, and this is something that's still being developed. How do we plan for upgrades and replacement of equipment around the intersection? A lot of agencies are operating equipment that is relatively outdated. So how do we plan for, can we use this information to better plan for how the system's operating? All right, so transforming from reactive to proactive, so we have the traditional process. It's relatively linear. It starts with complaints, or we're on a temporal retiming project, comes along every 3 to 5 years. We go through the process of collecting data, we do the design, and then we do the installation. The recommended process is that we start with a set of agency goals, we examine the context of the facility, we formulate objectives, identify performance measures, then select strategies and tactics that are implemented at the intersection. And this is a circle, so we're always doing this. We're always gaining an understanding of how we're achieving objectives and if we're able, if we're getting closer to meeting the organization's goals. This next slide, I actually have to credit to Vermont DOT. This is an outcome of working on the traffic signal strategic plan for Vermont. They did a scanning tour and were actually able to go out and get a look at this technology, but the approach has been more, let's focus more on the organizational management component of this, and let's develop a strategic plan and determine how we might incorporate these measures. So typically what happens is we work backwards, so we start with the measures, we select the objectives, we look at the context and the goals. So this will be an example of working backwards through this. So the performance measure will be yellow and red actuations. That's a basic function of every traffic signal. Every signal has an objective of safely transferring the right-of-way. It applies to all context. So whatever the traffic demand is, it doesn't matter where you are on the network, if it's the central business district, urban, suburban, linear, doesn't matter if it's freeway interchange, and it doesn't matter what the user mix is or the organizational's capability. This objective applies to all traffic signals. And of course, this is related to a goal of safety. So when we start talking about adoption, adoption is how you use the measure, and using the measure needs to connect back to objective, context, and goal. So just to give you an example of how this works, this data actually came from Utah DOT, and of course the goal is safety, the context is all, and the objective is safely transfer right-of-way. And what they did here is, this is a diagram of a signalized approach. This is for an eastbound, it's phase 2, and this is 24 hours of data. So if you look along the bottom axis, that's 24 hours. The vertical axis is the time in this eastbound phase, and it's just showing the first 15 seconds of that phase. And this is every time this traffic signal serves the eastbound phase, we've collected that data. So we have the yellow time, the all red time, and then the upper sort of light red is when other phases are active, or opposing phases that are not compatible with the eastbound phase. Each dot represents an actuation at the stop bar. So imagine you're at a eastbound approach, there's a stop bar. Every time a vehicle pulls up to that stop bar, we get a dot. All right, and so vehicles arriving on yellow are fine. Vehicles arriving on red are fine. Actually, even arriving when the opposing phase is red is also fine, because we're at the stop bar. What we don't know, or we haven't added to this, is speed, right? So there is speed data. We know that these vehicles arrived at the stop bar detector. We don't know if they violated. But what we could say is that there is a greater potential for violation if they arrive during the yellow or during the all red, right? That's when we don't want them arriving. So we could say that the hours between 5 and 9 maybe don't operate as well as other times of the day where you don't have this density of vehicles arriving on yellow and all red. And so as an outcome of this data, Utah DOT was actually able to retime the splits and the offsets for this intersection so that they have fewer vehicles arriving on yellow and all red. All right, so we're going to go through another example, and we work the other way. So if we started with mobility, all right, so our goal is mobility. And for context, we're going to say this is for traffic demand that's light to moderate on a linear arterial. So what would the objective be? The objective is smooth flow. So we're on a linear arterial, light to moderate traffic. We think the vehicle should be able to drive down the arterial without stopping. We call that smooth flow. And our performance measure is the Purdue coordination diagram, which we will give you more detail on in Sean's presentation. That's effectively a diagram that shows, again, the status of the intersection, red, yellow, and green, when the vehicles are arriving, so we can gain an understanding, are the majority of the vehicles arriving on green, which is what we want. If they're not, then we have the data to make those adjustments. Okay, so for everyday counts, our mission statement is to accelerate the implementation and adoption of automated traffic signal performance measures to advance objectives and performance-based approaches for managing traffic signal programs. Of course, we're going to touch the goals of mobility, safety, state of good repair, and quality of service for all users. So what does our current footprint look like for adoption? So there were 11 states involved in the pool fund study. About, I think, 7 or 8 of them have actually implemented automated signal performance measures. I think right now we're up to close to 3,000 signals just in the state DOTs. Georgia's manages about 9,000 signals. I think they're up to close to 3,000. Utah has just under 2,000 signals and about 85% of their systems on the system. Wisconsin and Minnesota and Indiana are all sort of continuing to grow their systems almost on a daily basis, and we'll talk about how this is implemented. And then there are a number of local agencies. We'll hear from one of them, Overland Park, Kansas, to share their experience with automated signal performance measures. And I'm going to turn it over to Sean. And I guess before I do that, are there any questions up to this point that we could address?
Before I begin my presentation, I really want to thank Eddie for inviting me out here. And you know, as a local agency, as he discussed, I spend a lot of my time on complaints. And so sometimes we're kind of stuck in the trenches of the day-to-day battles. And actually, Overland Park is the headquarters for Sprint, and we invented the cell phone complaints. So they call us the most complaints is the intersection to their entrance to Overland. Their main entrance is where I get my most complaints. Notice that, because they all seem to have complaints. So it's been really nice to have this innovation driven at a higher level for us, because sometimes I just don't have time to think outside the box. So it's been very helpful. As I mentioned, I'm with Overland Park. I've worked for Overland Park for 15 years, and my daughter likes to point out I have the gray hair to go with it now. And it's, you know, at Overland Park, as my time there, I've seen a lot of change. And this is actually one of the more interesting developments I've seen while I've been at Overland Park. Just to give you a little idea, it's a little hard to see, but we're a suburb of Kansas City in the metro area. We're a relatively young city. We were incorporated in 1960. We're a part of Johnson County. There's about 180,000 residents, and you know, we're a top 10 place to live. Back when I started the city, Money Magazine was a cool place to be in the top 10. Now we're a top 10 place to live in niche, according to their website. It was more of a joke. It seems like every city is in the top 10 list for somebody, so ours is niche. I had to work really hard to find that. So I've never heard of niche before this presentation, but we are in the top 10 there. But I guess this goes along with my point. You know, in Overland Park, it is a good place to live and raise a family. But unfortunately for me and my job, it's kind of hard to see, but the number one problem that citizens have in Overland Park is actually traffic congestion. And we keep getting worse and worse on these surveys. We do these surveys every 2 years, and we always rank at the bottom, which is a good thing, because safety and police is always highly rated. And the only thing we have to complain about in Overland Park is the traffic, and we're definitely not New York. So you know, given this mandate, we've spent a lot of effort and time to upgrade our systems. We spent about $10 million. We've installed about 100 miles of fiber optic cable. We've upgraded all of our controllers. We installed a new traffic signal system as part of a regional management signal system. We've also in CCTV cameras, and we've even put up some arterial DMS. You know, and one of the more novel ideas, they were talking about the traffic management plan. That's one of the things we decided to do, was come up with our own little traffic management plan and to document some of our objectives that we had never documented before. So where are we right now? We have 265 intersections, as I mentioned. And we are fortunate to have fiber communications. We like to use a mix of different detection technology, from intrusive to non-intrusive. And our fire department loves preemption, so we have preemption everywhere. And our central system is been developed by TransCore. And then we're very fortunate for the number of signals to have 2 engineers and 2 technicians for operations and 4 signal maintenance staff. You know, as my career in Overland Park, I had the opportunity to start working for I call him a master traffic engineer. You know, when I started, my boss, Gary, had 20 years of experience, and he was definitely a timing Jedi. As his young apprentice, he would often explain to me why we were doing things, and he just took me under his wings, and we kind of learned as we went along. We were a small group, and everything was just understood. He eventually went the way of the Force and moved on, and he left me to be the Jedi, and I had my young apprentice come up. And my young apprentice, he had the opportunity to question me on everything. He was one of those engineers that couldn't accept anything we did, and he's questioned us. But about that same time, we had the opportunity to attend a course where we talked about coming up with your own traffic operations plans. And as part of that, we actually sat down and we documented what we were doing. And this was a first for us. And as part of this, we had that discussion of why, and that young engineer was able to question me on everything, and we were able to talk about what we did. And this is the first time we'd actually documented it. And for us in Overland Park, our most important thing is to clear queues. So we always want to make sure people get through the light. The next most important thing was traffic flow on our main arterials. We always want to make people be able to get through a series of lights and hit green lights as they go down the road. The third thing was delay. We're trying to avoid delay. And then the last thing, but which ends up causing us more grief than anything, is stopping for nothing. As people drive down, as we've actuated all of our intersections in Overland Park, in the middle of the night, if someone has to stop at a light where they didn't think they have to stop, they'll typically call me and say, that's not working. So we have a lot of people calling us when they have to stop at nothing, which makes sense. I'm embarrassed as I drive down the road and have to stop for nothing. So we documented these, and this was a big start for us, and this ties into this whole performance here in just a second. You know, as we went through this management plan, I think in the city, we do a really good job of managing peak periods. And, you know, we go through and we do our designs, and we actually schedule things out. And in Overland Park, traffic most of the time is pretty typical. But, you know, the process that we had at the time to monitor what we were doing is probably where we were the weakest. Everything was manual. So we would do travel time runs, we would do turning movement counts, and we do observations. And everything we did, our travel time runs, we would only do once a year. And we were pretty aggressive with that, but we had so many roads, we could only get them done once a year. And so we were judging our system based on one particular sample. And I think as the young Jedi coming up, wanting to take over, I realized that was where our problems were. And so I've known for the longest time that we needed to automate this. And personally, I don't like driving up and down in traffic because it's just tiring, and counting cars is not why I went to college. But so automating it would provide us better coverage for the weekends, and we knew that if we would free up staff, and we could also try to work on some of our trouble spots. So we tried on our own to develop our own performance measures based on some of the data that our existing signal system was collecting. It was good information, but it was kind of hard to see some of the trends. I personally kind of enjoy that. I'm kind of the mad scientist, and I go through and I've tried to create different graphs and reports, and I've tried almost every tool out there that you could try because it was kind of fun and new. But in the end, we weren't quite getting to where I knew we could be. And so after trying things on my own, I was able to see a couple webinars, and there was one webinar that the Indiana DOT talked about how they had this beautiful $1 million cabinet, and this $1 million cabinet could collect all these performance measures and all this data. And I liked the idea, but I knew there was no way I was ever going to be able to buy a $1 million cabinet. Everybody at the city thinks I spend too much money as it is. So later on, I was really excited when I saw another webinar by Utah DOT and Indiana and Purdue, where they talked about how they were collecting the same type of data that they were collecting from this $1 million cabinet from their existing traffic signal controllers. And they were actually using the controllers that we use in the city. So this got my attention. So after watching the webinar, being the good geek, I called the Utah DOT contact up like within an hour of the webinar and said, hey, by any chance, could you set this up for us? And at the time, the Utah DOT was working with AASHTO, and they had some resources so they could set it up for us in the city. So they remoted in, and they set everything up on a server for me, and then we went ahead and configured all of our intersections in the system. And so to kind of give you, going along with what Eddie said, to give you an idea of how the system works, first you have a signal controller that's able to collect the data, and most of the manufacturers are able to do that now. And it collects data on as status change. So every time a light turns green or a signal picks up, it records that in 1/10 of a second. Now, so the server then there's a server back at your shop that goes out and collects that data periodically and brings it back and puts it into a format that's been specified. No, collecting all the data is great, but I think where the biggest innovation came was how they were visualizing the data. Some of the innovations that they had is they allow you to see 24 hours worth of data and be able to make sense of it. Maybe the public may not be able to make sense of it, but with a little bit of experience with the data, you can really start to see things very quickly. The top graph is kind of hard to see, but this is and I can show you later on. This will tell you how cars are arriving, and then the bottom one will tell you how your signal's operating, and so you can see very quickly how it's doing over a long time period. So what do you need to get going? As I mentioned before, for a minimum, you'll need a traffic signal controller that supports collecting the data. You'll need a server, and typically that server will be running a Microsoft SQL Server, and then you'll need the suite of software that was developed. And then for additional performance measures, you'll need some type of detection. Sorry. So if you're new to this and where you start, if you're trying to start from scratch, the first place you want to start is using this almost like the Maslow's pyramid for human needs. There's this Maslow's for traffic operations. You'll need to start, if you can, you want to build off a strong communications backbone and then move up to detection. And then with that allows you to work on your timing and your coordination. In Overland Park, as I mentioned, we spent a lot of time and money building our communication system. When I started the city, we were using RF modems and using our cable television network, and that was kind of a fiasco because of just poor communication. So we were able to upgrade, and about that same time, we decided to actuate all of our signals, and we went from inductive loops to non-intrusive detection. And so my experience with this is, unfortunately, the detection idea was good and bad, and sometimes we've had some issues with our non-intrusive, so we had to spend a lot of time on the detection and getting it going. So automated performance measures helped us do our job more efficiently. As I mentioned, we were stuck doing a bunch of detection troubleshooting, and these tools allowed us to troubleshoot that and actually allows us to jump forward and start working on some of the timing issues that actually need our time. For example, the system can help you see intermittent issues and also some of the performance like split failures, how are the offsets, how are the lights synchronized, if that's working well, is it still working well, and getting an idea of how long people are waiting and how the corridor is working. We currently, as I mentioned, we're using it for detection issues. We have an adaptive project that's in the works, and we're going to use that to evaluate it. And then we're also starting to use it as we're looking at retiming and the need for retiming. I guess one thing that I've always wanted to do was only retime the signals that really needed it. You know, there's a few corridors in Overland Park. Being the traffic engineer, I have it memorized. I know exactly when the light turns green. I let the guy beside me speed up and hit the light. I know just to drive, this is the speed limit, and you're going to cruise right through it. And the traffic in some of those corridors never changes. So there's no need to retime them. And there's probably not a lot of need to go out there and do travel times every year and spend 2 or 3 hours just making sure it's doing what we think. So this should allow us not to have to do that and only study the areas that we need. This is an example of how we're using it for intermittent detection issues. The y-axis are the phases, and the x-axis is time of day. And this particular one, you can see the number 5 represents our northbound left turn. The northbound left turn was red in the middle of the night, and that means this was a video detection unit that was sticking on in the middle of the night. I actually had this recorded in our video management system, and I was able to go back and see, hey, based on that graph, hey, there is a problem, and I need to go out and readjust the zones, and so we made that change. And so now, after the change, you can see that we fixed it, and now everything's green. So it's just a very visual, quick way of finding the intermittent detection. You know, without this system, or without these graphs, I could have found it by reviewing 24 hours of video, but I didn't have to do that. This system allows you to quickly find it. So in addition to some of the detailed graphs, the system also provides some high-level executive summaries. And these summaries are for intersections, corridors, and regions. And, you know, since the DOT staff, the developers were part of the DOT staffs, they came up with some automated reports to let them know about things like, as Eddie mentioned, detection issues, communication loss, stuck detectors, ped stuck, and if splits weren't getting enough time. And the system automatically alerts them of these things. So as a takeaway, from what we found, it's a great way of looking at data. It's another tool in your toolbox. And, you know, I really believe that this is a great first step. I'm plugging for Eddie and his group to keep pushing and getting funding to help us along. I think there's some other places that we can improve on. Enhanced reporting. I would like to see a little more comparison. Is this Tuesday different from the last Tuesday or the last 10 Tuesdays? Something like that. And also, this data is good, but you'll still need to take time to look at it. As Eddie mentioned, there's new software coming out. The new software is not quite Microsoft Office that you can just take a CD and plug it in. It does typically takes a little bit of effort and time by consultants or vendors. And, you know, as Eddie mentioned, is part of the Everyday Counts 4 program. So Overland Park, what are we doing? We like this so much that we're working with our system vendor to have it collect data, the once per second data, and put it into the this Utah DOT format. So we can use some of our older controllers. Not all of our controllers support it, but we're going to work with our system vendor to collect data from our old controllers. We plan on upgrading all of our controllers so we can do that, collect the data natively. And I guess we're also working, as these new performance measures come out, matching them to what our operations are. Because right now, some of our objectives are not matched to performance measures on the system that we have. And with that, I've gone kind of quick. If there's any question, or do we want to wait till the end? Or
Any questions?
And I'm happy to chat with you later if you'd like. Go ahead.
You said you installed 100 miles of fiber?
Yes, sir.
Underground?
Yeah, they were all underground. We're a fairly new city. For us, it was possible. And
In the roadway and just
in our right-of-way. Part of the trick we did was we convinced the city manager. We're a fairly long city, so we were able to convince everybody that was a good idea to connect up all of our buildings. Before, we were trying to do wireless, and so the maintenance departments wouldn't come up, or the police station wasn't getting communication in the middle of the rainstorm. So we put fiber between all of our buildings, and as we went by a traffic signal, we hooked it up. So
state funds? That was all state funds?
no, it was all local.
All local?
All local. At the time before this, we were able to get this going before before the economy had a downturn.
If you would use the mic.
What kind of detection are you guys using? You mentioned inductive loops, and then you went to non-invasives. Is it radar or video? Or
we're using video, and then we're transitioning to radar now.
Okay, so you're having issues with video, like false calls, things like that, or
Yes.
what's okay? All right.
Yes.
Thanks.
No, the whole video, that's another presentation. I can happy to talk with you offline on, I mean, this system allows you to understand the performance of that. I think sometimes some agencies put detection technology in, but they're not able to monitor it. This will tell you exactly how well it's working. Go ahead.
Yeah, I just have to say, when Eddie started talking, I was getting frustrated, and when you talked, I was getting envious, and then there was a little hope at the end. In our area, when the state puts in a signal, then it's turned over to the community, I'm sure like you. In Maine, we have 4 MPOs. That's probably about 2/3 to 3/4 of the signals in the state, so the towns are responsible for the maintenance thereafter. We have 2 part-time technicians that work on 120 signals. I was envious of hearing about 8 for
Sure.
that many. And then I hear the city say, as long as they turn, red, green, yellow, we're happy. And so they're not putting the money in. But one of the things you said that I think you went over fairly quickly that gave me hope was the survey that the municipality did to bring up this issue, because my sense is that the public is frustrated, but the towns don't know how to get the money or whatever. So I think that sounds to me like that might have been a key point in being
Sure.
able to say we're going to spend that money. Would you agree with that?
Yes, that survey definitely drove that investment into traffic signals. And that's why we did get some federal funding for some of our projects where we would put fiber in, but the majority of this was city money, and that was based on that. Yes, there was definitely a need and a desire for that.
I just wondered if you did any type of communication or outreach to the general public so that when that person that takes off fast at a green light doesn't mess up your performance measures because they're queuing up at the next light waiting for it to turn green?
That's probably something we could do more of. As an engineer, we try to stay low key. We've been doing it for a while, so most people that are from the area kind of get to know that, and they'll tell people not. On some of our bigger corridors, most people know not to speed just because they won't make the lights if they do. That's probably something we could work on, is the communication aspect of it. And I guess one last comment I would say, a lot of Eddie's work in AASHTO, this innovation project, has really pushed the vendors to make progress in this. Before this project came out, system vendors would just be like, this has driven a lot of innovation in the industry, and without this project, it wasn't going to be there. A lot of times they're waiting for us to come up with things as engineers, saying, what do you want, what do you want? And we're busy doing things, and we're like, we could do it better, but this has definitely driven the industry. Most of the central system vendors have integrated this directly or incorporated these types of reports in their products now. So it's not something completely isolated any longer. It's becoming mainstream in our industry.
Thanks, Sean. So one of the items I wrote down while Sean was speaking is, Sean, you called yourself a traffic signal geek, and I actually think of myself as a signal geek too. And one of the things that signal geeks, if you can show them this information, they immediately gravitate towards this because they understand the power of these measures. And on the note about vendors, I think if any of you have talked to a traffic signal engineer about an issue you've had at an intersection, you've probably felt frustration because they tend to talk about things like detection, communications, control. Here's all the stuff that I need to fix the problems. But I think the performance measures gives them the tool that they need to actually demonstrate and articulate how what they're doing on a day-to-day basis is making an impact. All right, so I think I'm queued up here to the next part of this. All right, so what I'm going to do now is actually talk about EDC 4 in terms of our approach to implementation. All right, so every implementation team, every technology team is tasked with putting together an implementation plan. And I've put together a team to do this for the ATSPM technology. I have a technical team. We've got a group of people from the resource center and headquarters that make up our leads for the technology. And then we have a set of folks that are from our field offices. And then we also have a private sector advisory group who we're meeting with next week in Indianapolis to present the approach to them, understand the products that they have, and understand how we can all work together. Sean presented sort of one option for implementing this particular technology. There are a number of private sector products that have actually also been under development and have been implemented in a number of locations. So we want to make this a holistic approach to implementing the technology. So how do we not only bring in this open source sort of homegrown approach to implementation, but also how do we purchase or procure products to actually implement this? So just to give you an idea of who's on the team, you can see the list of technical team folks is pretty extensive. Most of them are work in agencies that have implemented the technology. I think the only exception to that is John Ty with the City of Anaheim. Over on the right is our FHWA team, and so our hope is that this can be a very division office or FHWA division-centric approach to implementation so that they stay plugged in. With adaptive control, I also led that initiative, and I'll show you in a few moments. A lot of our target audience is down at the local agency level. And so we tend to step on a few toes if we bypass our division office and go straight to locals and we bypass the state. Everyone wants to know what's going on. And so having our division office folks engaged was very important to us. Our implementation plan has these components. We've talked through this morning a lot of the description of the technology, benefits. I'll talk a little bit about challenges. I've given you the mission. And I'll talk to you the goals, objectives, and strategies for how your state might get involved with implementation of this technology. Just to reiterate the benefits, the big ones are transforming from reactive to proactive, improving safety, efficiency, and reliability, and then, of course, supporting a state of good repair. Okay, so what are the challenges? And I guess I already sort of tipped my hand on this. I'll go to the dispersed audience first. There are over 3,000 agencies that operate and maintain traffic signals in the United States. Only, or less than 2% of those, if we include Puerto Rico, the Virgin Islands, and Guam, are state DOT level agencies. So, you know, well over 70%, actually more than 90% of the market is local, county, MPOs, you know, at that level, towns, boroughs. So the challenge is how do we communicate with them? How do we work through the states and through the division offices to get this down at the local level? The other aspect, and I think Sean touched on this in his presentation, is organizational capability. And I heard workforce mentioned during the general session. Shifting from an objectives to performance-based approach to managing is going to be challenging because we really don't have the workforce that understands how to use this type of data to make changes. Although I think it is a lot less rigorous than the traditional approach in terms of collecting turning movement counts, churning information through models, and implementing stuff on the street. We're well set up to do that in this industry. The shift will be a little daunting to do, but we have a pretty good set of peers to help us get through that process. The other issue is the state of the infrastructure. There are a number of agencies that have begun to, I guess, not deploy as much detection as they used to. There are a lot of approaches that don't have detection on the coordinated phase. You might have detection on the side streets, but not on those main street phases that are coordinated. And if you want to collect data about arrivals on green, how are we serving the travel time or reliability for that main street, we will need detection there. So that's another challenge. And then, of course, as someone mentioned, there's resources for operations and maintenance. A lot of this falls not into the capital improvement category, but ongoing O&M. So how can you capitalize those projects? I think there are some examples of how to do that. And it's certainly allowed through a lot of the federal aid programs that exist. It's just how do you actually do that? How do you make that trade-off? Okay, so again, on the mission statement, I'm going to focus here on the word adoption. We have a number of agencies that have already implemented or are in this space where they've been working on Sharp 2 plans to develop approaches for better managing their signals. So for those agencies, we're really going to focus on how do you not just have the technology, but actually use it to understand how you're achieving your agency's goals. How do you articulate how you're doing better at design, operations, maintenance, and management? For the other tier, I think we're going to be looking at more at awareness and implementation. Based on my observation, a lot of agencies will implement this technology and then they learn how to use it after it's been implemented. Very few people read the owner's manual, before they buy a TV or anything. So, you get the technology in hand and then you learn how to use it. We will have a systems engineering approach to help agencies understand what their needs are. If I was to go into the goals, so the goals are accelerate adoption, cultivate awareness into implementation, and then lastly, increase awareness. I think AASHTO AII from 2013 to 2016 has been incredibly effective at increasing awareness to where I think we can focus with Everyday Counts 4 primarily on goal 2 and 1. So we'll really be focusing on getting from implementation or awareness to implementation, and then for those that have implemented, how do we get them into adoption? And there's a whole good set of peers that can help us to accomplish this. Utah DOT, I describe this agency as the Disneyland of traffic signal operations. They have really oriented their operation around active, proactive management of not just signals, but bridges, pavement, everything. It's a very proactive organization. So they are sort of our shining example of what it means to adopt traffic signal performance measures. And so what they've done is prior to implementation of this technology, so this is 2015 and prior, this is how they had their asset management tiers. And you can see traffic signals are in tier 2. And so for tier 1, that's the highest value, it's a high risk, high financial impact for poor management, but most importantly, items that are in tier 1 tend to be well funded and have sustainable funding sources. So as an outcome of implementing performance measures, they were able to move their traffic signal assets from tier 2 to tier 1, and they have a whole set of measures that are on their organization's dashboard that they track for traffic signals. So they've rolled a lot of these very intersection-oriented measures up to higher level measures that they report to their management. All right, so what are the strategies for accelerating adoption? A lot of this is going to be peer-to-peer exchanges. We've actually had a pool fund meeting last week, so we're actually expanding the pool fund. There's some new topics that are coming up, and so there'll be an opportunity for agencies that are not a part of the pool fund presently to join it. We'll also be doing a lot of case studies, so looking at the organizations that have implemented, what are the items that they've put into traffic signal strategic plans or management plans. FHWA has a course, an NHI course on developing traffic signal management plans. So we'll definitely be offering that. We'll be doing technical assistance and training in that aspect of this. And then there's also, under the Sharp 2 program, a traffic signal capability maturity framework that's been developed. And so that'll help an agency evaluate where are they in terms of business processes, systems and technology, workforce, and performance measures, and put together an approach for how they might bring this into the organization and use it. Other strategies to advance, so shifting from adoption into implementation. So this is how do we move from that awareness stage to now let's start to get the performance measures implemented. Again, a lot of this is just increasing awareness. So there'll be the traditional webinars, workshops, peer exchanges, but what I've added to this is product demonstration showcase. I think implementation requires agencies understanding all of the implementation options, and I'll share with you a few of these on a few slides that get into some of the private sector options for this. For implementation options, we've categorized agencies by capability. So, Utah is sort of this high resource agency, and if you're a high resource agency, that gives you maximum flexibility and maximum power for implementation, because you could choose to do this in-house, you could contract it out, or you could do one of the vendor options where you might bring in a vendor that will collect all this information and provide it back to you. Moderate resource agency, and I might put Overland Park in this category. You guys are sort of teetering right on that high resource to moderate resource, but they're probably looking for something more in terms of a turnkey option. We just want the measures, we want access to the data. How do we implement this without bringing in a lot of new staff or having to train our staff? And then the minimum resource agency are the ones that probably very likely will have to contract this out, because they won't be able to increase the capability of their workforce to incorporate this into their day-to-day operations. Sean mentioned the SPM source code. So Utah DOT developed a set of software to do data analysis. So there's two components. There's data collection, there's data analysis. The data collection I'll get to on the next slide, but this data analysis portion is they've effectively automated the analysis of all the data. So there's, you probably saw some pictures of that website. All that data is pulled in. You can select various measures and display those. They've opened that up to anyone that wants to look at it. For Utah, a number of the other agencies that have implemented have chosen not to publish this on the web. But the tools to do all of the analysis and display of the data are available using open source software. Utah is actually contributing this software under the Apache license, which is one of those where you can download it. You don't necessarily have to contribute anything back. But it'll be available on FHWA's open source application development portal on November 15th. So we're working to have that stood up, and it'll be available. They're also doing a training in January, sort of a train-to-trainer. We anticipate that consultants will be very involved in this space, so if you need to hire support to implement the software and configure it for you, there'll be technical assistance from Federal Highway, or you could hire a consultant to do this for you. In terms of the infrastructure that you need, if you're going to go with this open source option, you would need to have one of the high resolution capable controllers. And there's a list of those. I got pictures, so if you're very familiar with these, you'll recognize, oh, I have the yellow box or the blue box. But virtually all of the vendors that provide traffic signal controllers have a high resolution data capable controller. If you're using the 2070 variety, that might just imply a firmware update. But I think Utah tried to make some estimates, and they think that to deploy this on a system of, say, 500 intersections will cost the agency, if they have the infrastructure, somewhere between $3,000 to $50,000, depending on how much outside support you need. And again, that, there's a licensing requirement for the database software that you need for this, and I think a number of organizations already have this SQL license. Okay, so implementation resources. I guess the official line for this is there's the January 2017 Train the Trainer workshop in Utah. Under EDC, we are learning from that workshop, and we will stand up consultant support to repeat this open source software implementation and configuration option. We will do this in July 2017, so every 6 months, right? July 2017, January 18, and then July 2018. There will be pretty active peer-to-peer support. We found that is probably one of the best mechanisms, sharing information, doing this technology exchanges with your neighboring states and local agencies. And then there'll also be a fair amount of technical assistance. To mention the pool fund, these were the states that were involved. There are 2 publications that came out of the pool fund. In addition to the higher resolution data specifications, there are 2 documents, one that talks about every single one of these measures, all of the computational background and theory, and then there's one that gets into agency, organizational management that talks about how to bring these measures into an organization and use them. Vendors have been involved in this. Indiana has brought them in throughout the process, and there are a number of other branches that have come off of this. So Minnesota DOT developed I think they developed a smart traffic signal. It's a product, and it's actually now become live traffic data. But what this company offers is basically for free, at no charge to the agency. They want to go into a data sharing arrangement where they will provide all of the infrastructure to collect and analyze the data. And that's, you sign an agreement to provide the data, and they provide this data to NRICS, to Google, to others, and this is probably going to become very relevant under connected vehicles. So that's something that's also coming up. Census Networks, Wavetronics, and MyoVision are also in that space. And then I've listed all of the other vendors that have been involved. So a number of implementation options. In terms of raising awareness, a lot of the same items you see for adoption and implementation, but this is more about just exposing agencies to this technology. And that'll be the traditional stuff. I was very surprised to learn with adaptive control that an advertisement in the ITE journal was their first exposure to adaptive control. So we very likely will see advertisements in professional journals. In terms of where we are for implementation, we've looked across a number of initiatives, and we sort of identified the states that we think are sort of primed for adoption versus implementation versus awareness. So if the state has a color, that means that we're very focused on that state and want to work with you to bring more information about this technology to your state. If you're a gray state, and we did the Everyday Count Summit in it was Baltimore, and Kentucky was there, and so I want to invite Dwayne Thomas to come up and talk about how Kentucky is approaching the implementation of ATSPM.
Thanks, Eddie. I just wanted to talk a little bit about Kentucky's story. As I mentioned earlier, I was the state traffic engineer in Kentucky for about 5 years before I left to work for Federal Highways. And during my time with the state DOT, I worked through AASHTO and the National Committee on Uniform Traffic Control Devices. And so I had a lot of exposure to the other states and the other agencies that were doing similar work. But the one thing I took away most was that while we did similar activities, there were a lot of different approaches in how you did that. So I'll tell you a little bit about Kentucky. They have about 3,000 traffic signals that are maintained by the state DOT. Kentucky, as far as the state DOT, there's 12 districts, and we're pretty decentralized for the most part, except in the area of traffic signals. And as someone mentioned earlier, the workforce and the lack of being able to keep the people that do this type of work around and in those jobs is a big challenge, and it's no different in Kentucky. The central office has a lot of signal expertise and does a lot of these activities, but they go out and install signal systems across the state, and then they leave, and it's up to the district traffic staff or the locals to keep that operating. And so that is definitely one of the challenges. But as I said, Kentucky has about 3,000 traffic signals that the DOT maintains, and then the 2 major cities, Lexington and Louisville, have about another 1,500 that they maintain on their own. Kentucky has been doing signal systems for a long time. We show up on the map as a gray state, which means we haven't really been engaged in this current activity. But they've been doing signal systems for a long time. But it started out, performance measures were really more looking at outputs. How many traffic signals needed to be interconnected in a system, developing a list of needs to develop projects and request funding in our highway plan, and then keeping a schedule of how many we've actually worked on and implemented. But it's, like I said, it's really more of an output as opposed to an outcome. Kentucky, as they started to lose staff, they went to consultants to do some work in the signal systems area. They currently have 3 statewide consultants that they can deploy to work on different projects, and that kind of pushed them a little further along performance measures to looking at outcomes, but it was really at a pretty basic level, doing the before and after studies and travel time, so it didn't really leave you with a good way to monitor and to know what's going on after the work was done. So that's really the big benefit of this system for Kentucky as they move into this, is to be able to become way more efficient and automated. Now, there are some challenges they're going to have. They rely mostly on 170 controllers, which is an older version, and it doesn't collect high-resolution data. So one of their infrastructure challenges they're going to have to overcome is getting a more modern traffic signal controllers in the field, and also the mainline detection that was mentioned earlier. They have detection on the side streets and the turn lanes, but there really wasn't a need to have detection on the main line. But with this system, that's something that they're going to have to address to be able to collect data for the mainline traffic. Some of the benefits of this initiative, again, I think, is efficiency and automation. There's so many cliches about doing more with less and working smarter and not harder. This is a case where you actually would be able to do some of those things instead of just talk about them. The other thing is a lot of the measures that you're able to do with this system is it puts things in layman's terms. I know it's challenging when I was with the DOT to try to explain what we were doing and how we were helping when you would go ask for more additional funding or staff to do more of the great things we were doing, but we had a hard time really communicating that to our leadership. This allows you to measure and put it in terms of things not only the everyday driver can understand, but also management can understand. And so I think it improves that dialogue to where you can actually show the progress you're making and making improvements for our customers, which would allow you, again, to be able to justify and ask for more staff or more resources in these programs. And then also monitoring and the maintenance backlog. If you did nothing else, just knowing which detectors were out before somebody had to call and tell you. There are just some basic things you can pick up with this before you fully take advantage of all the capabilities that would show a big improvement. So Kentucky's implementation, I think Eddie had the chart up there that kind of showed the 3 steps were awareness, implementation, and adoption. Kentucky's probably between awareness and implementation. Because like I said, they've been doing a lot of these things for years, but just in a different way. And so they do have some infrastructure challenges they're going to have to overcome. But I was really excited to hear that they're interested in this. So regardless of where your state or local agency is with regard to the 3 steps here as far as awareness, implementation, and adoption, there's an entry point that's available for you to work and then work your way up to adoption. So that's just kind of a picture of where Kentucky's at. And as I said earlier, we're pretty excited that they're going to be looking into this. And as the division office with FHWA, my role is going to be to facilitate, but help them get to the right people. They're probably not going to look to us to be the experts in the division office, hopefully, but we're going to put them in touch with the right people through the peer-to-peer exchanges, the workshops and training, and to basically find ways to make them successful. And that's the role I'm going to be playing, and I'm looking forward to that. Thank you.
All right, thanks, Dwayne. Okay, so to wrap it up, I guess what I'd like to do is just say, hey, how can FHWA work with you under EDC4 to progressively advance implementation? For a lot of agencies that have implemented, I'd use maybe Tucson or Richardson, Texas as an example. They stood up 1 corridor, so less than 10 intersections. Seminole County, because of the infrastructure that they had, they were very quickly able to implement the technology, and because of the benefits they saw, quickly distributed it to all 334 of their traffic signals. I think Overland Park did something very similar. So I think it's important to get this tool in the hands of your traffic signal engineers. So that's probably the most important aspect of it. Once they see it, you do not have to sell this. I think when I first became aware of it, I instantly understood the power of the data that it provided. So I just encourage you to consider this as you go into your caucuses, and thank you for joining us. Are there any questions?
I'm just curious, Sean, I think you said you put $10 million towards your project. So do you have any matrices, like what are anticipated expenses or to get something like this started for a community?
The $10 million was mainly for our fiber infrastructure. So this project, I didn't even tell management about it. I just did it and snuck it on a server and that we had sitting there. So for us, the cost was very minimal on this performance, and it was just using existing detection that we have. And I guess I didn't want to scare anybody off. One of the advantages of this system is we built a signal system that requires once per second data. This system does not require that type of communications. You can even have spotty communications. It goes out and gets it and brings it back. So that's kind of the beauty of this system. It works independent, and it doesn't require $1 million traffic signal system to operate. Now, it can be part of a $10 million or $1 million traffic signal system, but it doesn't have to be. I implemented this on an old, it was actually the hardware from an old installation of a signal system that I had. So I had old hardware, I stuck it on it, and it's running on that right now. So it doesn't have to be super fancy.
Any other questions? All right. Thank you. Appreciate it.